Hello students, welcome to ST.SEBASTIAN Pre-University College. In the previous video we studied about position, path length and displacement. In today's class, let us study about speed and velocity. Now let us study about speed. Now speed is defined as the time rate of change of distance of a particle is called speed. Speed is the rate of change of distance of the particle is called speed. Rate of change of distance of a particle means the changing the position of the particle with respect to time is called speed. Speed is equal to distance travelled upon time taken. Distance travelled upon time taken. It is denoted by speed, the small letter v, that is equal to distance. We can represent it by s divided by time is represented by t. So speed is the rate of change of distance of a particle is called speed. Expression is v is equal to s upon t. S distance travelled and t is the time taken. Speed is a scalar quantity. Speed is a scalar quantity. Speed is either positive or zero but never negative. Speed is either positive or zero but never negative. Speed of a running car is measured by speedometer. So, speed of a running car is measured by a speedometer. It's a device which is used to measure the speed of vehicle. A speed of running car is measured by speedometer. So here the speedometer is a device which is used to measure the speed of vehicle. Speed is measured in centimeter per second, which is also represented in cm s to the power minus 1 in CGS system of units. In SI system of units, we are using the unit for a speed is meter per second, meter slash s, that is meter per second, which is also represented by ms to the power minus 1. Another unit for a speed is kilometer per hour, kilometer per hour. In practical life, when distance and time involved are large, so kilometer per hour which is used in a practical life, in a practical way we are using these units to measure the large distances and time. Then we are using kilometer per hour. So here in general, we are using the SI system of unit for a speed is meter per second. Now, let us see the uniform speed. The name itself, it's a uniform. Uniform means there is a uniformity, isn't it? A particle or a body is said to be moving with a uniform speed if it covers equal distances in equal interval of time. However, the small these intervals may be. So, the uniform speed in the sense a body is covering equal distance in equal interval of time. The body is covering equal distance in equal interval of time, then the body is under uniform speed. So, there is a example of car. A car is moving in a straight road with a uniform speed. So it travels equal distance in equal interval of time. The next one, variable speed. A particle or a body is said to be moving with variable speed if it's covered unequal distances in equal interval of time. However, a small these intervals may be. That means a variable speed in the sense the body covers unequal distances in equal intervals of time. So there is a in our diagram we can see that the car is traveling with a variable speed. It covers unequal distances. The distance is not equal at each time. Interval is remains same, but the distance is different. That is variable speed. The third one, average speed. When a body moves with a variable speed, the average speed of the body is the ratio of the total distance travelled by it to the total time taken. So average speed, that means we are going to take average value. How you are going to take average value? You are going to adding all the distances divided by all the time, isn't it? So similarly here also the average speed, that is equal to the ratio of the total distance travelled by it to the total time taken. Total distance travelled upon total time taken, that is average speed. It is represented in terms of expression. We can write average is denoted by AV, speed is represented by small letter v. So average velocity is equal to the total distance travelled is represented by the distance travelled is s. So here TOT is a total distance travelled divided by T is for a time. So total time taken is TOT, that is total time taken. So uniform speed, variable speed and average speed. Uniform speed, that bodies covers equal distances in equal intervals of time. Variable speed, the bodies covers unequal distances in equal intervals of time. Average speed is the ratio of total distance travelled by it to the total time taken. Now let us see the instantaneous speed. When a body is moving with variable speed, the speed of the body at any instant is called instantaneous speed. Instantaneous speed means at particular instant of time, what is the speed of the body? That is known as instantaneous speed. Now, here the instantaneous speed, the speed of the body at any instant is called instantaneous speed. Now let us see the position time graph. So here it is a graphical representation of position and time. For considering a body is moving along a straight line. So this is a graph where the position is along the y-axis and time along the x-axis. Such a graph is known as position time graph. So the position is represented by x and time is represented by t. See, in the previous slides you observed that the position is represented by x and time is represented by t. The position unit is meter, the time unit is second. Now the first graph, that is along the x-axis we are represented the time, along the y-axis we are represent the position. So the first graph, it is for a stationary object. If the body is does not moving, then the graphical representation is becomes constant. So the first graph, that is for an object at rest, the position time graph is a straight line which is parallel to the time axis, that is a stationary object. In the second graph, for an object moving with the uniform speed, the position time graph is a straight line inclined to the x-axis, that is shown in the second diagram. An object in a uniform motion. Uniform motion in the sense an object it covers equal distance in equal interval of time. Therefore, we are getting a straight line. In the third diagram, that is an object in a non-uniform motion. So, an object moving with a variable velocity, the position time graph is not a straight line. So, here for a variable velocity or non-uniform motion, object keep on changing its speed with respect to time. Now, let us see the velocity. Velocity, the time rate of change of displacement of a particles, is called velocity. The rate of change of displacement of a particles is called velocity. Velocity is equal to displacement by time taken. So, velocity is a vector quantity. Therefore, we are represented the velocity with the arrow symbol that indicates it's a vector. The velocity and speed both are represented by the same letter, that is V only. Vector V is equal to vector S. S is a displacement divided by T. T is a time. Vector V is equal to vector S divided by T, where time is a scalar quantity, displacement is a vector quantity, velocity is a vector quantity. Velocity is a displacement to the time taken. Velocity is a vector quantity. The direction of velocity is the same as the direction of displacement of the body. Direction of the velocity is the same as the direction of a displacement of the body. Velocity can be either positive, 0 or negative. Velocity can be changed in two ways. One is by changing the speed of the body. Another one is by keeping the speed constant but by changing the direction. These are the two ways we can change the velocity of body. Which are the two ways we can change the velocity? By changing the speed of the body, or else by keeping the speed constant but by changing the direction. Speed is constant but we can change the direction. Then the velocity is going to change. Or else we are going to change the speed of the body. These are the two ways we can change the velocity of the body. Velocity is measured in centimeter per second, that is in CGS system. Under SI system we are measuring the velocity in meter per second. In practical we are using kilometer per hour. 1 meter per second, that is equal to 18 divided by 5 kilometer per hour. So 1 kilometer per hour is equal to 5 by 18 meter per second. So 1 meter per second is equal to 18 by 5 kilometer per hour. 1 kilometer per hour is equal to 5 by 80 meter per second. So 1 kilometer per hour, which is equal to 1000 meter divided by per hour. We are going to convert it into second. That means 60 into 60, that is 3600. So it becomes 5 by 18. So 1 kilometer per hour is equal to 5 by 18 meter per second. Therefore 1 meter per second is equal to 18 by 5 kilometer per hour. Now let us see the uniform velocity. So same way what we studied for a speed, similarly we have to study for a velocity and even for a acceleration also. Uniform velocity. A particle or a body is said to be moving with a uniform velocity if it covers equal displacements in equal intervals of time, however small these intervals may be. So uniform velocity in the sense a body covers equal displacement in equal interval of time, then it is uniform velocity. Variable velocity. A particle or body is said to be moving with variable velocity if its speed or direction both changes with time. So variable velocity in the sense a body is keep on changing its speed or direction with respect to time. That is variable velocity. Average velocity. When a body moves with a variable velocity, the average velocity of the body is the ratio of total, which is also called net displacement covered by it, to the total time taken. Average velocity, which is equal to ratio of net displacement to the time taken. The representation of average velocity, vector v, av is the average, that is equal to total displacement, that is vector s divided by total time. For a body is moving with uniform velocity, then we can write average velocity is equal to u plus v divided by 2. It's not acceleration, it's velocity. Okay, so there is a formula. Average velocity is also defined as the change in position or displacement delta x divided by the time intervals delta t in which the displacement covers. We can also use the formula for a average velocity is equal to x2 minus x1 divided by t2 minus t1, where x2 and x1 are initial position. x2 is the final position, x1 is the initial position to the time interval, final time interval to the initial time interval. The x2 minus x1 we can write it is the change in displacement, that is delta x. t2 minus t1 we can consider as delta t. No effort or force is required to move the body with a uniform velocity. So these are the types of velocity: uniform velocity, variable velocity, average velocity. Uniform velocity, the body covers equal displacement in equal intervals of time. Variable velocity, the body, it is under a variable velocity and it's keep on changing its direction and speed with respect to time. Average velocity, it is a ratio of net displacement to the total time taken. So the representation of average velocity under the position time graph, we will get P1 and P2. So average velocity for a net displacement to the total time intervals. P1 and P2, these are the two different positions with respect to x1 and x2. T1 and T2 are the time intervals. So under the P1 and P2, these are the 2 points with respect to the position x2 and x1. T1 and T2 are the time. The slope of P1 and P2, it gives the average velocity. Now under the position time graph, the representation of uniform velocity. So the position time graph, the position along the y-axis and time is along the x-axis, then such a graph is known as position time graph. So the first diagram where x and t graph for a stationary object. X is the position, t is the time graph for a stationary object. For an object at rest, the position time graph is a straight line which is parallel to the time axis. That is the first diagram. The second one, xt graph for an object with a positive velocity. For an object moving with the uniform velocity, the position time graph is straight line, inclined to the x-axis. Xt graph for an object negative velocity. For an object moving with decreasing velocity, that is negative velocity, the position time graph which is shown in the diagram, the decreasing. Now let us see the difference between the speed and velocity. Speed is the time rate of change of distance of a body, whereas velocity is the time rate of change of displacement of the body. Velocity is the rate of change of displacement of the body. Speed is the rate of change of distance of the body. Second one, the difference between the speed and speed tells nothing about the direction of the direction of motion of the body. Velocity tells the direction of motion of the body. So here the speed tells the magnitude of the body, velocity tells the direction of the body. Speed is a scalar quantity, velocity is a vector quantity. Speed of the body can be positive or 0, but velocity can be positive, 0 or negative. Average speed of the moving body can never be 0. Average velocity of moving body can be 0. So these are the difference between the speed and velocity. Thank you, students.